Let's take a look at question number 15 for section DS in the GMAT official guide for 2015. In this question, we are asked what the cube root of w is, which is the same as w to the power of a third. We have one variable, w, so all we need is one equation to solve for it. In condition 1, we are given one equation. And in condition 2, we're given one equation as well. So chances are good that D is our answer for this question. Let's take a look at the conditions individually. Condition 1 says that the fifth root of W is equal to 64, which is the same as 2 to the power of 6. Then, if we take the power of 5 on both sides, we have 2 to the 6th to the power of 5, which is the same as W being equal to 2 to the 30th. But what we want to know is the cube root of W, so that's 2 to the 30th, and then take another power of a third, which gives us 2 to the power of 10. We've solved for W, and condition 1 is sufficient. What about condition 2? It says the 15th root of W is equal to 4, which is equal to 2 squared. And if we take power of 15 on both sides, then we have W being equal to 2 to the power of 2 to the power of 15, which is again 2 to the power of 30. So by the same reasoning, the cube root of W is 2 to the 10. So condition 2 is also sufficient, and the answer becomes D. This way of problem solving is called the variable approach method, and nowadays is the most proven and effective way of getting a correct answer in the DS section of GMAT Math.
Now let's take a look at the official guide 2016, DS number 12. And we're going to use the variable approach method. And looking at the question, there are many variables because we have to know all the terms. So in order to match the number of variables to the number of equations, we need many equations as well. And the condition 1 provides one equation, and the condition 2 provides one equation. And there's high chance that E is going to be our answer choice. So using the condition 1 and 2 at the same time, if we write sequence as Sn, and the question is, what is S105? According to the condition, Sn plus 1 equals Sn plus 10. And S1 equals negative 8. So S2 becomes 2, S3 becomes 12. And we can find S105, which is a unique value. So the condition 1 and 2 become sufficient, and the correct answer choice is C.
Let's take a look at question number 18 for the DS section in 2015 official guide for GMAT. It says that at the bottom, at the first row, we have 18 seats total. And then for the next row, we have 2 additional seats that we can represent like this. 18 plus 2 seats. And then the next row, we have 2 additional seats for a total of 18 plus 2 times 2 seats. Do you see the pattern? For the first row, we have 18 seats. Second row, we have 18 plus 2 seats. Third row, we have 18 plus 2 seats. So if we have n rows, then how many seats do we have in the nth row? We can represent that using 18 plus n minus 1 times 2 seats. Okay, we have one variable then, and we only need one equation to solve for one variable. And in condition 1, we're given one equation. In condition 2, we're given another equation, so chances are high that D is our answer. Well, let's take a look at condition 1 in detail. It says that there are 27 rows in the theater, which means n is 27. So 18 plus 27 minus 1 times 2 is 70. When we compute this out, it's 18 plus 20 plus 22 plus all the way to 70. And this is an arithmetic sequence sum. So the way to do this is we take half of the number of elements in the sequence times the first element plus the last element. This becomes 27 times 44, which is equal to 1188. So condition 1 is sufficient. And notice that for condition 2, it has the same information as the first condition, because it says the last row has 70 seats, and we've already computed 70 seats, so condition 2 is also sufficient. This means that our answer is D. This sort of problem solving is called the variable approach method, and nowadays it's the most proven and effective method of getting a correct answer on the DS section in GMAT Math.
Next, we're on the official guide, 17 version, DS section, question number 243. Now let's start off by looking at the original condition and counting the number of variables. We have two variables, u and v. This means we need two more equations. Two equations to solve this problem. Now option 1 gives us one equation, as well as option 2. So we have two equations in total, and so chances are C is our answer. Let's look at 1 and 2 together and find out. We have u equals 1 and v is larger than 2. And we're comparing u to the power of v and v to the power of u. Now the first bit, 1 to the power of v, will always be 1. And then v to the power of u, v is 2, so this will always be greater than 1. So overall, u to the power of v will always be smaller than v to the power of u. So this is a unique answer, which means this is sufficient. So choice C is our answer.
Let's take a look at Official Guide 2016, DS number 14. So I'm going to use the variable approach method and modify the original question and the condition. So the range becomes highest price minus lowest price. So there are three variables because we have the range, which is R, and H and L. And there's only one equation in the original question, which is R equals H minus L. So in order to match the number of variables to the number of equation, we need two equations. So there's one equation in the condition 1, there's another one in the condition 2. And there's high chance that C is our answer choice. So looking at both the condition 1 and 2, and first we're going to look at the condition 1. The condition 1 is basically saying that the total number of wallets multiplied by 1/3 equals 24. And this is basically out of scope. This cannot be true. And looking at the condition 2, we have the lowest price is 1/3 of highest price, and the range cannot be found using this equation. So the answer is not unique, and both conditions are not sufficient, and the correct answer is E. The condition 1 is out of scope, and the condition 2 is not unique.